Have you ever wondered why there is a planet closest to the Sun, scorched by daytime temperatures reaching 430 degrees Celsius, yet plunged into -180 degrees at night, and still it endures, still it turns, still it quietly tells its story across 4.5 billion years? Tonight, we journey to Mercury, the smallest yet most resilient stone in the solar system, a place where time flows so strangely that 2 days last longer than a single year. Find a quiet place. Close your eyes if you can. Take a deep breath, then slowly let it go. Allow this sound to move through you like waves of light traveling from a distant place. In the moments ahead, we will travel together, not only through space, but through time, through layers of meaning where science and philosophy gently intertwine. If you are searching for a story about the universe told in a different way, scientifically grounded yet as soothing as a lullaby, tap like and subscribe so you do not miss the journeys to come. I am truly grateful that you chose to spend this time here with me, together, in the vastness of the cosmos. Mercury is not just a planet. It is a question. A reminder. A mystery we are only beginning to understand. Missions like NASA's Messenger spacecraft orbited it more than 4,000 times, captured over 270,000 images, and each one revealed a little more of the strange nature of this tiny world. And now, the Bepicolombo mission, led by the European Space Agency and the Japan Aerospace Exploration Agency, is on its way, set to arrive in the year 2026, carrying with it an entirely new set of questions. But before we dive into the numbers, the orbits, the magnetic fields, and the scarred surface of this planet, let us pause for a moment. Breathe. Because sometimes, to understand a planet, we must first understand ourselves, how we see, how we feel, and how we exist within the quiet flow of time. On a clear night, when you look up at the sky, you can see the moon. You might spot Venus shining brightly, notice the red glow of Mars, and if you are lucky, even catch Jupiter. But Mercury? Mercury is like a ghost, always there, yet almost never willing to show itself. This is not a coincidence. It is your first quiet lesson about position in the universe. Mercury orbits the Sun at an average distance of just 57.9 million kilometers, about 2.5 times closer than Earth. From our point of view, that means Mercury never strays more than 28 degrees from the Sun. Imagine standing on a stage, with the Sun as a massive spotlight at the center. Mercury is forever hiding inside that beam, like a tiny dancer who is never allowed to step out of the main light. Ancient astronomers gave Mercury many different names. The Greeks called it Apollo when it appeared in the morning, and Hermes when it showed up in the evening, believing they were two separate stars. In China, it was known as the metal star. The Maya tracked it with remarkable care, recording every appearance and disappearance, as if they were trying to catch the ghost of time itself. But the real secret is not just about distance. It is also about light. To see Mercury, you have to look during dawn or dusk, moments when the sky is still flooded with brightness. Sunlight scatters through Earth's atmosphere, creating a glowing veil that washes everything out. And Mercury, far dimmer than Venus, is simply swallowed by that glow. Scientists estimate that only about 5 to 10% of people on Earth have ever truly seen Mercury with their naked eyes. Nicholas Copernicus, the man who reshaped our understanding of the cosmos by placing the Sun at the center instead of Earth, is said to have never seen Mercury in his entire life. This may be only a legend, but it reveals something profound. Sometimes, the things closest to us are the hardest to see. Pause for a moment. Slow your breath. How many things in life are like Mercury? Truths that are always there, right in front of us, but hidden by the glare of something bigger and brighter. Emotions we cannot quite name. Relationships we have never fully seen for what they are. Modern scientists need powerful telescopes and complex instruments to capture Mercury. They must calculate the exact moment when it reaches its greatest distance from the Sun in our sky, creating the widest viewing angle. Even then, the window lasts only a few weeks, and you have to know precisely where to look. NASA's Messenger spacecraft had to perform an extraordinary engineering dance to reach Mercury. It looped around Earth once, around Venus twice, and around Mercury itself 3 times before finally slipping into orbit in 2011. The journey took 6.5 years. Why? Because getting closer to the Sun is not as simple as flying straight in. Gravity would pull you down too fast. You have to slow yourself, step by step, using other planets as anchors to bleed off speed. It is a beautiful metaphor, isn't it? To reach the truth, we often cannot rush directly toward it. We have to take the long way around. We have to slow down. We have to be patient. When Messenger finally settled into orbit, it sent back more than 270,000 images, each one a fragment of a much larger puzzle. They revealed a battered world, scarred by millions of craters, towering cliffs rising kilometers high, and a massive iron core that makes up about 85% of the planet's radius. But before we dive into its surface and structure, let us pause and feel what Mercury teaches us first. That seeing and understanding are not the same thing. That some truths require tools, time, and the right perspective. And that the hardest things to see are not the least important. So if Mercury is so elusive, how did it become such an important part of astronomical history? How did ancient scientists, without telescopes or computers, manage to track it at all? And more importantly, how did those observations change the way we understand ourselves? Imagine living in the 16th century. You believe Earth sits at the center of the universe, that everything else revolves around us. That is not arrogance, it is simply what your eyes tell you every day. The sun rises in the east and sets in the west. The stars wheel across the sky overhead. Everything appears to move around you. But one small rocky world, named Mercury, would help shatter that illusion. The story begins with Claudius Ptolemy, a Greco-Roman astronomer living in the 2nd century. He built an intricate model of the cosmos, where each planet traveled along small circles that themselves moved along larger circles around Earth. For most planets, this system worked reasonably well. But Mercury was always a stubborn exception. Mercury moved too fast. It appeared and disappeared in ways that were hard to predict. Its orbit was not perfectly circular, in fact it was an ellipse with the highest eccentricity of any major planet. That means its distance from the Sun changes dramatically, from about 46 million kilometers to 70 million kilometers. From Earth, its motion looked strange, irregular, impossible to fully explain with the old models. In 1543, Nicholas Copernicus placed the Sun at the center. His heliocentric model explained much more, but it still was not perfect. Copernicus believed planetary orbits had to be perfect circles, because in the philosophy of his time, the circle was considered the most perfect shape in the universe. Then came Johannes Kepler. In the early 17th century, Kepler did something few dared to do. He let go of the circle. He discovered that planets move in ellipses, with the Sun sitting at one of the 2 focal points. And Mercury, with the most pronounced elliptical orbit of all, became a crucial piece of evidence for Kepler's first law. But the story does not end there. Close your eyes for a moment and travel forward to the 19th century. Astronomers had been watching Mercury for centuries, carefully recording every time it passed in front of the Sun, an event known as a transit. They calculated its orbit with increasing precision. And then they noticed something unsettling. Mercury's perihelion, the point where it comes closest to the Sun, was shifting. With each orbit, that point moved slightly. Using Newton's law of gravity, scientists could explain most of this motion through the gravitational pull of other planets. But there was still something missing. 43 arcseconds per century. A tiny number, but one that refused to go away. 43 arcseconds. That is 43 out of 3,600 parts of a single degree. Over an entire century. A difference so small that most people would shrug and say it does not matter, probably just a measurement error. But scientists did not shrug. They understood that the universe is not wrong. Our understanding is. Some suggested there must be an undiscovered planet hiding between Mercury and the Sun. They searched for decades. No planet appeared. The problem was not a hidden world. The problem was Newton's law itself. In 1915, Albert Einstein published the theory of general relativity. He proposed that space and time are not a fixed stage, but a fabric that can bend under the influence of mass. The Sun, with its enormous mass, creates a deep curvature in spacetime. And Mercury, so close to the Sun, feels that curvature more strongly than any other planet. When Einstein applied his equations to Mercury, the result was exact. 43 arcseconds per century. No extra tweaks. No hidden planets. Just a deeper understanding of how reality truly works. Take a slow breath. Feel the weight of that moment in history. A small rocky world, millions of kilometers away, became the key to unlocking an entirely new way of understanding the universe. Mercury did not just support general relativity. It became its first and most important test. It showed us that space and time are not separate, rigid things. They are a single, flexible, living structure. That clocks tick more slowly near massive objects. That light itself can bend. That the universe is stranger, more beautiful, and more complex than we ever imagined. And here is the quiet miracle. All of this began by paying attention to a tiny detail. 43 arcseconds. A discrepancy most people would ignore. But science does not ignore. Science asks, why? Our lives work the same way, do they not? The small things we brush aside, a lingering discomfort, a subtle inconsistency in someone's words, a recurring dream, sometimes they are signals of deeper truths waiting to be uncovered. Mercury teaches us to notice what does not quite fit. Not to rush past anomalies. Because sometimes, it is precisely the imperfections, the things that break the pattern, that open the door to a greater truth. So now that we know Mercury changed how we understand reality itself, a new question emerges. How was Mercury born in the first place? How did such a small world survive in the most extreme neighborhood of the solar system? And what does its origin story reveal about the nature of existence itself? Let's rewind time. Take a deep breath, and imagine drifting backward 4.5 billion years. There is no Earth as we know it. No life. Only a vast cloud of gas and dust slowly swirling in the darkness of space, the primordial solar nebula. At the center of this cloud, gravity tightens its grip. Matter compresses. Temperatures rise. Pressure builds. Then, in a quiet but miraculous instant, a critical threshold is crossed, nuclear fusion ignites. Hydrogen fuses into helium. Light erupts. The Sun is born. But Mercury's story does not begin as a planet. It begins as countless tiny fragments orbiting this young star. Close to the Sun, where temperatures can soar into the thousands of degrees, only the most heat-resistant materials can survive. Silicate rock. Heavy metals like iron and nickel. Lighter elements, hydrogen, helium, water ice, are swept away by the fierce solar wind, pushed outward to colder regions where they will later become Jupiter, Saturn, and the gas giants. Slow your breathing. Feel the heat of that primordial fire. Mercury was born of fire, not a poetic flame, but a violent, purifying, destructive one. Fragments of rock and metal begin to collide. Slowly at first, then faster. Gravity pulls them together. Each collision generates heat. Each merger creates a larger mass with stronger gravity. This process, called accretionary collision, unfolds over millions of years. But Mercury has something unusual. Its metallic core makes up about 75 to 85% of the planet's radius, the highest proportion in the entire solar system. Earth's core accounts for only about 50%. Venus and Mars have even less. So why is Mercury so different? There are three main hypotheses, and all of them involve violence. The first hypothesis is that the young Sun was simply too hot and too powerful. The solar wind, a stream of charged particles blasting outward from the sun, stripped away much of Mercury's silicate rock mantle while the planet was still forming. What remained was the heavy metallic core, clinging to its orbit through sheer gravitational strength. Imagine someone standing in a firestorm. Their clothes are torn away. Skin is stripped off. Only bone and heart remain, the core, the heaviest part, the hardest to destroy. That is Mercury. The second hypothesis is a giant impact. In the early solar system, collisions between protoplanets were common. Mercury may once have been far larger, perhaps 2 or 3 times its current mass. Then another massive body slammed into it at an unimaginable speed. The impact tore away and blasted off most of its rocky outer layers, leaving behind a planet dominated by metal. Modern computer simulations from NASA and research institutions have recreated this scenario. They show that a collision at just the right angle and speed could produce exactly the structure we see in Mercury today. The third hypothesis involves temperature and pressure. Near the Sun, metal-rich dust grains condense more easily than lighter silicate compounds. This means Mercury may have formed from the very beginning with an unusually high metal content, without the need for any extraordinary catastrophe, just the laws of physics and chemistry operating in an extreme environment. Data from space probes adds another twist. Spacecraft analyzing Mercury's surface chemistry have found unexpectedly high levels of potassium, a volatile element. If Mercury had undergone extreme heating or a massive impact, potassium should have evaporated long ago. But it is still there. This suggests the story may be more complex, a combination of all 3 factors. Mercury may have formed metal-rich from the start, then been further eroded by the solar wind, and perhaps also reshaped by one or more major impacts that finalized its structure. Close your eyes and consider what it means to be born in the harshest place. It means enduring. It means shedding what is unnecessary. It means facing fire and keeping only what can last. Mercury is a lesson in survival. It was not born in gentleness. It was not nurtured by comfort. It was forged by heat, by violence, by loss. And from all of that, it became a small but incredibly dense world, with the heaviest and strongest iron core, and something even more surprising, its own magnetic field, in a solar system where most other rocky planets have lost theirs. Yes, you heard that right. Mercury has a magnetic field. It is about 100 times weaker than Earth's, but it still exists, a lingering shield from a more dynamic past, when its molten iron core was hot enough to drive convection, to power a dynamo, to generate magnetism. NASA's Messenger spacecraft discovered that Mercury's magnetic field is asymmetric, stronger in the northern hemisphere than in the southern. No one knows exactly why. There may be complex structures inside the core that we do not yet understand. Perhaps layers within layers, solid iron at the center, liquid iron surrounding it, sulfur dissolved toward the outer regions. Each discovery opens new questions. And that is the beauty of science, not final answers, but deeper steps into the mystery. Exhale. Let this origin story settle in. Mercury is not just a planet. It is a reminder that sometimes the harshest conditions create the most enduring things. That loss can reveal essence. That to survive near the flame, you must become something the fire cannot consume. And now, a new question emerges. If Mercury was born from violence and stripped down to its core, how did it survive for 4.5 billion years? What does its surface look like? What stories do the scars on its skin tell about time itself? Take a short pause. Take a sip of water. And then we will step onto the surface of Mercury, a world of shadow and blinding light, of extreme heat and cold, of scars that never heal. Imagine standing on the surface of Mercury. There is no air to breathe. No wind to feel. Only absolute silence, a silence so deep you can hear your own heartbeat inside your spacesuit. Ahead of you, the sun hangs in the sky, 3 times larger than it appears from Earth and 7 times brighter. Its light pours down like a flood, unfiltered by any atmosphere. The temperature around you reaches 430 degrees Celsius, hot enough to melt lead, zinc, and tin. But step into the shadows, just a few steps into a deep crater, and the temperature plunges to minus 180 degrees Celsius. A difference of more than 600 degrees across just a few meters. This is a world of extremes. Mercury's surface looks a lot like the Moon, covered in countless impact craters. But there is one crucial difference. On the Moon, you can see dark regions formed by volcanic lava that once flowed across and filled ancient craters. Mercury also had volcanoes, but its lava was not dark. Its chemistry was different, it reflected light differently, creating a surface that is relatively uniform in color. NASA's spacecraft mapped Mercury's entire surface, 100% of it. This has never been done for any other planet besides Earth. And what they discovered completely changed how we understand this world. There is a massive crater called the Caloris Basin, 1,550 kilometers wide, one of the largest impact craters in the entire solar system. It formed about 3.8 billion years ago, when a huge object, likely around 100 kilometers across, slammed into Mercury at tens of kilometers per second. That impact sent shockwaves rippling through the entire planet. And on the exact opposite side, 180 degrees away from Caloris Basin, something strange appears. Chaotic hills and jumbled fractures, created when those shockwaves converged at the antipodal point, tearing the surface apart. Pause for a moment and think about that. A blow to one side of a body can leave a wound on the other. Mercury remembers violence, not just where it happened, but everywhere, even at the farthest possible distance. But another kind of landscape surprised scientists even more, towering cliffs. They rise hundreds of meters high, stretch for hundreds of kilometers, and cut straight through older craters. Which means they formed after those craters already existed. These cliffs are evidence of contraction. As Mercury cooled, very slowly over billions of years, its massive metal core shrank. And as the core shrank, the entire planet followed. The surface was compressed, folding and cracking, pushing up cliffs and scarps. Scientists estimate that Mercury's radius has shrunk by about 7 kilometers since it formed. 7 kilometers may not sound like much, but for a small planet only 4,879 kilometers across, it is a profound change. These cliffs are geologically young. Some are only a few 100 million years old. Which means Mercury is still shrinking, still changing, still alive, in a slow, silent way that cannot be seen directly but can be measured through its scars. Take a deep breath. Feel what that means. Change is not always fast or obvious. Sometimes it happens over millions of years, millimeter by millimeter, yet it still leaves marks that can never be erased. NASA's missions uncovered another mystery. Mercury is far darker than expected. Its surface reflects only about 10 to 12% of the sunlight that hits it, even darker than the Moon. Why? It turns out Mercury's surface is rich in carbon, in the form of graphite. This carbon may have come from comets and asteroids that struck Mercury over billions of years. Or it may be the remains of a primordial magma ocean, a layer of molten material that once existed beneath the surface and carried carbon upward as it cooled. Then there are the strange bright hollows, small, shallow depressions with irregular shapes. They appear all over Mercury, especially inside relatively young craters. No one knows exactly how they form, but the leading idea is that certain minerals on Mercury's surface are vaporizing under the intense sunlight, leaving these voids behind. This means Mercury is slowly losing material, one atom at a time, into space. It is fading, very slowly, in the sun's light. Over billions more years, volatile minerals will disappear entirely, and the surface will change again. Yet there is one place on Mercury where something survives against all odds, the poles. In 1991, astronomers using radar from Earth detected unusually strong reflections from Mercury's polar regions. This kind of reflection is characteristic of water ice. Water ice? On the hottest planet in the solar system? It sounds insane, but it makes sense. Near Mercury's poles are deep craters that sunlight never reaches. Scientists call them permanently shadowed craters. Inside, temperatures stay below -170 degrees Celsius. And there, water ice can survive for billions of years. Not just water ice, but organic compounds too, substances like toluene and benzene, preserved in eternal darkness. The raw ingredients of life, frozen on the hottest planet of all. Close your eyes and feel the paradox. Light and shadow existing side by side, separated by only a few meters. Extreme heat and extreme cold, with no middle ground. Mercury is a world of opposites, no blending, no compromise, only sharp boundaries between extremes. And within those boundaries, we find stories. Of impacts 4 billion years ago. Of the slow contraction of a cooling metal heart. Of atoms drifting into space, second by second. Of ice preserved in darkness, waiting for something no one can name. Mercury's surface is not just rock and dust. It is a diary. Every scar is a page. Every crater is a paragraph. And if we know how to read it, if we look closely enough and measure carefully enough, we can understand not just the history of Mercury, but the history of the entire solar system. So if Mercury remembers the past through its surface, how does it experience time? How can a single day on Mercury last longer than 2 of its years? And what does that reveal about the true nature of time in the universe? A single day on Mercury, from one sunrise to the next, lasts 176 Earth days, nearly 6 months. That is how long someone standing on Mercury would have to wait to see the sun return to the same spot in the sky. But here is the strange part. Mercury completes one orbit around the sun in just 88 Earth days. That means a year on Mercury is shorter than a single day. In other words, 2 Mercury days are longer than 3 Mercury years. How is that even possible? The answer lies in a phenomenon called spin-orbit resonance. Mercury rotates on its axis extremely slowly, one full rotation takes 58.6 Earth days. At the same time, it completes one orbit around the Sun in 88 days. The ratio between these two motions is 3:2, a perfect resonance. This means that for every 3 trips around the Sun, Mercury rotates exactly twice on its axis. And during those 2 rotations, from the perspective of someone standing on the surface, the Sun rises and sets only once. Close your eyes for a moment and feel the complexity of that. Time is not simple. It is not a steady, uniform flow that is the same everywhere. Time is an experience, shaped by where you stand, how you move, and how the universe interacts with you. But it gets even stranger. In certain locations on Mercury, if you stand there at just the right moment, you would see the sun rise, slow to a stop, slide backward toward the horizon, and then rise again. It sounds like science fiction, but this is real physics. Because Mercury follows a strongly elliptical orbit, its speed changes dramatically as it travels around the Sun. When Mercury is closest to the Sun, it moves faster along its orbit than it rotates on its axis. This creates a bizarre effect. From certain spots on the surface, the rapid orbital motion temporarily overwhelms the planet's rotation, making the Sun appear to reverse direction in the sky. Scientists call this the Joshua Tree effect, named after the biblical story in which Joshua prays and the Sun stands still in the heavens. Now imagine, just for a moment, that you are a living being on Mercury, even though such a thing could never exist. How would you experience time? One of your days would last half an Earth year. During the first half of that day, you would be scorched under direct sunlight at temperatures reaching 430 degrees Celsius. During the second half, you would freeze in darkness at -180 degrees Celsius. There is no gentle morning. No romantic sunset stretching across a few quiet hours like on Earth. Only a slow transition between 2 extremes, unfolding over many weeks. And if you lived long enough to experience 3 Mercury days, 528 Earth days in total, you would notice something else. The sun would not rise in the same place each time. Because of the 3-to-2 resonance, each day the sun rises at a different location on the horizon. Only after 3 days does the pattern repeat. Take a deep breath. Feel the difference between measured time and experienced time. A clock on Earth ticks forward in steady seconds. But for someone on Mercury, time would feel completely different, stretched out, with sunlight hanging overhead for weeks, and darkness swallowing everything for just as long. Einstein once said, "The distinction between past, present, and future is only a stubbornly persistent illusion." On Mercury, that illusion is bent in ways the human brain struggles to imagine. But there is another layer of time on Mercury we have not touched yet: general relativity. Remember that Mercury helped confirm Einstein's theory through the mysterious 43 arc-seconds per century. That discovery tells us something profound. Time on Mercury does not flow at the same rate as time on Earth, not by much, but enough to be measured. Near massive objects, time runs more slowly. Mercury orbits very close to the Sun, deep inside the strongest gravitational well in the solar system. This means a clock on Mercury ticks just a little bit slower than a clock on Earth. The difference is tiny, only a few microseconds per year. But it is real. It is measurable. And it reminds us that time is not an absolute, fixed thing. It is part of space-time itself, a fabric that can be stretched, bent, and twisted by mass and energy. If you were born on Mercury and somehow survived, you would age more slowly, even if only by a fraction, than someone born on Earth. Every heartbeat, every thought, every second of your life would last just a little longer than that of your sibling on Earth. This is not poetry. This is physics. Close your eyes and reflect. What is time? Is it something we measure with clocks? Or something we experience through consciousness? Or is it both, and they do not always agree? On Mercury, a second is still a second by physical definition. But a day is 6 months. A year is 3 months. And if you stand in the right place, the sun can rise twice in a single morning. Time is not what we think it is. It is more flexible, stranger, and deeper than our everyday experience allows us to see. That is why Mercury matters. Not just as a rock in space, but as a teacher, showing us that reality is larger than our intuition, that the universe contains ways of existing we never imagined. So now a natural question arises. If Mercury teaches us about time, what does it teach us about space? About magnetic fields? About the invisible forces that hold it together and shape its destiny? And how do those forces connect Mercury to the Sun, and to us? Most rocky planets in the solar system do not have a global magnetic field. Venus does not. Mars lost its magnetic field billions of years ago. The Moon never had one. Only Earth and Mercury do, and Mercury's magnetic field is about 100 times weaker than Earth's. So why does Mercury still have a magnetic field while the others lost theirs? The answer lies deep inside, within a massive iron core that makes up about 85% of the planet's radius. But the story is far more complex than simply iron core equals magnetic field. To generate a magnetic field, you need a dynamo effect. You need liquid metal in motion, creating convection currents, and those currents must be strong enough to generate and sustain a magnetic field. Mercury is small. And small objects cool faster than large ones, that is a basic law of physics. In theory, Mercury's core should have solidified long ago. But it hasn't. Why? Slow your breathing. Sit with the mystery. Sometimes, things that should not exist still do. And understanding why opens new windows into how the universe works. Scientists have several hypotheses. One of the most compelling is this: Mercury's core is not pure iron. It may contain dissolved sulfur or silicon. These elements lower the melting point of iron, much like salt melts ice on a road. That means the core could remain liquid at lower temperatures than pure iron would allow. Data from spacecraft support this idea. Probes have measured the way Mercury subtly wobbles as it rotates. The way a planet wobbles reveals clues about its internal structure. And the numbers suggest that at least part of Mercury's core is still liquid. But there is something strange about Mercury's magnetic field. It is not symmetrical. On Earth, the magnetic field is fairly balanced, with the magnetic north and south poles roughly mirroring each other. On Mercury, the field is stronger in the northern hemisphere than in the southern one. The center of the magnetic field, known as the magnetic dipole, is not located at the planet's center. It is shifted northward by about 20% of the planet's radius. Why? No one knows for sure. There may be asymmetric convection currents inside the core. There may be a thicker layer of solid iron in the south than in the north. Or the interior structure may be far more complex than we imagine, possibly made of multiple layers, each with different compositions and physical states. Mercury's magnetic field creates a protective bubble around the planet. But because the field is weak and Mercury is so close to the Sun, this bubble is small and fragile, only about 1 to 2% the size of Earth's magnetic shield. Close your eyes and imagine standing inside a thin, delicate bubble while a raging storm howls outside. The solar wind, a stream of charged particles made mostly of protons and electrons, blasts outward from the Sun at speeds of 400 to 800 kilometers per second. When this wind strikes Mercury's protective bubble, it is deflected and pushed aside, forming a bow shock, much like water flowing around a rock in a stream. But Mercury's shield is too weak. The solar wind often punches straight through it and slams directly into the surface. When that happens, high-energy particles strike the rocky ground and knock loose atoms of sodium, potassium, and calcium, creating an extremely thin atmosphere, called an exosphere. Mercury's exosphere is nothing like Earth's atmosphere. It is incredibly sparse, about 1 trillion times less dense than Earth's air. The atoms rarely collide with each other. They simply dance through space, born from the surface, rising upward, then either falling back down or being swept away by the solar wind. NASA spacecraft have observed a sodium tail, a long stream of sodium atoms blown away behind Mercury, stretching thousands of kilometers like a strand of golden hair in the darkness. It is direct evidence of loss. Mercury is slowly losing material to space, one atom at a time, without pause. But a magnetic field is not just a shield. It is also a window. When solar wind particles interact with a magnetic field, they can trigger processes known as magnetic reconnection. Magnetic field lines are stretched, broken, and then snapped back together in new configurations, releasing enormous amounts of energy. These energy bursts create magnetic substorms, events that on Earth produce auroras. Mercury has no auroras. There is no thick atmosphere for particles to collide with and glow. But the energy is still there, invisible and violent, shaping the space around the planet in ways we are only beginning to understand. Take a deep breath. Let this sink in. Protection is not always perfect. Sometimes our shields have holes. Sometimes the storm gets through. But existence is not about having an unbreakable shield. It is about continuing to exist even when the shield is flawed. Mercury has survived for 4.5 billion years with a magnetic field 100 times weaker than Earth's. It has lost material, stripped away by the solar wind layer by layer, atom by atom. And yet it remains. Still spinning. Still there. And the miracle is this: its magnetic field is still alive. Its core is still liquid, still moving, still generating magnetic lines that protect the surface, imperfectly and frequently breached, but present nonetheless. Maybe that is a lesson in resilience. That you do not need to be perfect to endure. That you do not need to be invulnerable to survive. That sometimes, a fragile but persistent shield is enough. Bepi-Colombo, a mission currently on its way to Mercury, carries more advanced instruments to study the planet's magnetic field. It will measure it with unprecedented precision, create more detailed maps, and perhaps finally help us understand why this magnetic field still exists when, by all expectations, it should not. Until then, Mercury keeps it secret. And maybe that is part of the beauty, that even as we learn so much, there are still deep mysteries waiting. And one final question lingers. Mercury has a magnetic field, a fragile protective bubble, and even water ice at its poles. Could it have once hosted life? Could it ever host life in the future? And what does the question of life on Mercury reveal about how we define habitability itself? Mercury is one of the most extreme places in the solar system. Daytime temperatures soar to around 430 degrees Celsius, hot enough to melt lead, zinc, and tin. At night, they plunge to -180 degrees Celsius. There is no atmosphere to trap heat, no shield against radiation. There is no liquid water on the surface. The solar wind slams directly into the planet, stripping away atoms one by one. By every ordinary definition, Mercury is a dead desert, not just lifeless, but seemingly incapable of supporting life at all. And yet, science has taught us one important lesson: never underestimate life. On Earth, we have found life in places that once seemed impossible. In hydrothermal vents on the ocean floor, where temperatures reach 400 degrees Celsius, pressure is crushing, and sunlight never arrives. In acid lakes with pH values close to zero. In salt ponds 10 times salter than the Dead Sea. Deep inside rock, kilometers beneath Earth's surface, where bacteria survive by eating minerals and do not need oxygen. These organisms, known as extremophiles, have radically expanded our definition of the habitable zone. If life can exist in acid, under immense pressure, in total darkness, then where does its true limit lie? Close your eyes for a moment and reflect. Is our idea of what is impossible shaped by the narrow experience of living on a single planet? Now return to Mercury. In 1991, when scientists discovered water ice at its poles, hidden inside permanently shadowed craters where temperatures remain below -170 degrees Celsius, a new question emerged. Could that ice be hiding something more? Spacecraft observations revealed not only water ice, but also complex organic compounds, including toluene, benzene, and possibly other carbon-based molecules. These compounds are the raw ingredients of life as we know it. They are not life themselves, but they are the building blocks that can lead to life under the right conditions. But conditions on Mercury are not right, at least not for life as we understand it. The ice is locked solid. There is no liquid water. No stable energy source. No complex chemical cycles capable of sustaining metabolism. So why do we keep talking about Mercury and life? Because Mercury teaches us another crucial lesson. The ingredients for life, water, carbon, energy, can exist in places we would never expect. And the boundary between possible and impossible is far less clear than we once believed. More importantly, Mercury has not always been the world we see today. Take a slow breath and travel back in time. 4 billion years ago, the solar system was much younger. The sun was weaker, shining at only about 70% of its current brightness. That meant Mercury, while still hot, was not as extreme as it is now. And perhaps, just perhaps, during that early era, as comets and asteroids delivered water and organic compounds to the inner planets, Mercury experienced brief, fleeting moments when conditions were slightly less hostile. There is no direct evidence for this. But absence of evidence is not evidence of absence. Mercury's surface has been battered, resurfaced, and transformed over billions of years. If traces of complex chemistry ever existed there, they would almost certainly have been erased long ago. Still, this is not the main reason Mercury matters in the search for life. The deeper reason lies elsewhere. Mercury helps us understand the true limits of the habitable zone. In astronomy, the habitable zone is defined as the range of distances from a star where temperatures allow liquid water to exist on a planet's surface. In our solar system, this zone stretches roughly from the orbit of Venus to that of Mars. Earth sits comfortably in the middle, in the so-called Goldilocks zone, where everything is just right. Mercury lies far outside this zone, too close to the Sun. Yet by studying it, we refine our understanding of where that boundary truly lies. How does a planet lose its atmosphere? How does stellar wind affect the ability to retain water? How does a magnetic field, or the lack of one, determine a world's fate? These questions are not just about Mercury. They apply to thousands of exoplanets we are discovering around other stars. Many of them orbit extremely close to their suns, even closer than Mercury is to ours. Could they host life? Under what conditions? Mercury is a natural laboratory. It shows us what happens when a rocky planet forms too close to a star. It reveals how atmospheres are stripped away, how water is lost, how radiation reshapes surface chemistry. And these lessons, tragic for Mercury itself, are priceless in our search for life elsewhere. Slow your breathing. Feel the weight of this idea. Mercury has no life, yet it helps us find life. It is a mirror, reflecting what Earth might have become if we had formed just a little closer to the Sun. There is a deep philosophical thought here. Sometimes, the value of something lies not in what it has, but in what it lacks, and in what that absence teaches us. Mercury has no life, but it has water ice. It has no atmosphere, but it has a faint protective envelope. It has no gentle surface, but it does have a magnetic field, weak and imperfect, yet still present. In all of these absences and contradictions, we learn something essential. Life is not just about having the right ingredients. It is about the right balance. The right distance. The right protection. The right timing. Earth is not lucky simply because it has water. It is lucky because it has an atmosphere thick enough to keep that water from escaping. Lucky because it has a magnetic field strong enough to deflect the solar wind. Lucky because it sits at just the right distance, not too close, not too far. And Mercury, by being everything Earth is not, helps us appreciate the miracle of life. There is one final thought we must consider when talking about Mercury and life, the future. Scientists sometimes speculate, half seriously, about terraforming Mercury. Could it ever be made habitable? Could we give it an atmosphere? Could we cool it down? The answer is probably no, at least not with any technology we can realistically imagine. Mercury is simply too close to the Sun. Any atmosphere we created would be stripped away by the solar wind within a few million years. And cooling a planet that receives 7 times more sunlight than Earth is a challenge far beyond our capabilities. But perhaps the real question is not, could we, but, should we? Maybe Mercury's value lies precisely in the fact that it is not Earth. That it shows us another way for a world to exist, without life, yet still beautiful, still complex, still full of mystery. As we explore Mercury, from its surface to its magnetic field, from its ancient past to questions about life, a new question quietly emerges. What is Mercury's future? What will it look like a billion years from now? And how is its fate connected to our own? Close your eyes and travel to the future. Not next year. Not the next century. But 1 billion years from now. 2 billion. 5 billion. You are drifting through space, looking down at Mercury. It is still there, still orbiting, still enduring the sun's glare. But everything has changed. Because the sun is not a constant. It is aging. And as it ages, it changes everything. 1 billion years is a span of time twice as long as complex life has existed on Earth. Long enough for continents to drift, oceans to form and vanish, species to evolve and go extinct millions of times over. But for Mercury, 1 billion years is just another billion years of endurance. Right now, the Sun is a main sequence star, fusing hydrogen into helium in its core. It has been doing this for 4.6 billion years and will continue for roughly another 5 billion. But here is the crucial detail. Over time, the Sun is getting brighter. Slowly, but relentlessly. The reason lies in nuclear physics. As hydrogen turns into helium, the core becomes denser. To maintain pressure against gravity, the core must grow hotter. A hotter core speeds up fusion. The result is that the sun brightens by about 10% every billion years. That may not sound like much, but for planets, it is the difference between life and death. In about 1 billion years, Earth will become too hot to sustain liquid water on its surface. The oceans will evaporate. The atmosphere will fill with water vapor. Ultraviolet radiation from the sun will split water into hydrogen and oxygen, and the lighter hydrogen will escape into space. Earth will become another version of Venus, dry, scorching, and lifeless. And Mercury? It is already dry. Already scorching. But it will get worse. Over the next 2 billion years, Mercury will lose even more material. The solar wind, growing stronger as the sun ages, will continue to strip atoms from its surface. Some minerals may disappear entirely. Mercury's magnetic field may weaken or vanish once its core finally cools and solidifies. No dynamo. No shield. The surface will be fully exposed to the solar wind and cosmic radiation. And the ice at the poles, those permanently shadowed craters where water has remained frozen for billions of years, may finally begin to disappear. Not because sunlight reaches them directly, but because the planet's overall temperature rises as the sun grows brighter. Water molecules, organic compounds, the last relics of a colder past, will drift away into space. But this is not the end. Eventually, the sun runs out of hydrogen in its core. Fusion there stops. The core contracts and heats up. A surrounding shell of hydrogen ignites. The sun begins to expand, slowly at first, then faster. It becomes a red giant. The sun's radius will grow by a factor of 100 to 200. Will it swallow Mercury? No one knows for sure. Different simulations give different answers. Some show the sun expanding out to Earth's orbit, consuming both Mercury and Venus. Others suggest that as the sun loses mass through powerful stellar winds, its weakened gravity allows planets to drift outward, letting Mercury survive on the outer edge of the red giant. But even if Mercury is not engulfed outright, it will be roasted by temperatures reaching thousands of degrees. Its surface will melt. Rock will turn to magma. Metals will liquefy. The planet's entire structure may be transformed. If it survives the red giant phase, when the sun finally sheds its outer layers and becomes a white dwarf, Mercury will orbit a stellar remnant, small and slowly cooling. The light will fade. Temperatures will drop. And for the first time in its existence, Mercury will be cold. Take a deep breath and feel the paradox. The hottest planet, at last, becomes a frozen world, not because it moved away, but because its star died. But there is another possibility, one that astrophysicists sometimes discuss with a mix of concern and fascination. Planetary orbits are not perfectly stable over immense spans of time. There are tiny disturbances, gravitational tugs from other planets, tidal effects, subtle interactions with matter in space. Most of the time, these disturbances are insignificant. But over billions of years, they can accumulate. Computer simulations of the solar system's dynamics suggest there is a small chance, about 1%, that within the next billion years, Mercury's orbit could become unstable. That instability could lead to one of three outcomes. First, Mercury falls into the sun, a swift death, a brief flash on the star's surface, and then nothing. Second, Mercury is flung out of the solar system, becoming a rogue planet, drifting through interstellar space, cold and alone forever. Third, Mercury collides with Venus or Earth, a planetary-scale catastrophe, producing a blast bright enough to be seen from neighboring star systems. These scenarios are not science fiction. They are real possibilities, however unlikely, calculated by physicists using n-body simulations that run millions of simulated years into the future. But in roughly 99% of all outcomes, Mercury simply keeps going. It continues to orbit. Continues to endure. Continues to exist, altered, eroded, transformed, but still there. Mercury may outlive life on Earth. It may watch our oceans vanish. It may see Earth turn into a desert. It may persist as the sun swells and then shrinks. And if it is lucky, it may orbit the sun's remnant for billions of years more, a relic of a once vibrant planetary system. There is a quiet sadness in this. Mercury, a small lifeless rock with no atmosphere, endlessly battered, may survive longer than all of us. It is a reminder that endurance is not always about strength. Sometimes it is simply about continuing to exist, day after day, for billions of years. Let's return to a simple question: why do we care about Mercury? It has no life. It can never be a place we live. It is just a small, scorching rock orbiting the sun, one object among countless trillions in the observable universe. So why do we send spacecraft there? Why have we spent decades studying it? Why are we, you and I, right now, spending time talking about it? The answer is not only found in science. It lies in something deeper, in how we understand ourselves by understanding other worlds. Mercury exists where it should not. Too close to the sun, too hot. Too stripped down. And yet it is still there, 4.5 billion years and counting. It does not complain. It does not surrender. It simply keeps turning. There is something profound in this wordless persistence. In our world, where we constantly search for meaning, for purpose, for reasons to keep going, Mercury reminds us that sometimes, existing is enough. No grand meaning required. No heroic purpose needed. Just continuing, day after day, is an act worthy of respect. The philosopher Albert Camus wrote about Sisyphus, condemned to push a boulder up a mountain forever, only to watch it roll back down and begin again. Camus concluded, one must imagine Sisyphus happy. Because within that endless, seemingly meaningless repetition, within persistence in the face of absurdity, there is a kind of freedom, a kind of rebellion. Mercury is the Sisyphus of the universe. It turns. It endures. It is stripped atom by atom, yet it remains. And perhaps, just perhaps, there is a strange kind of beauty in that silent persistence. Mercury is the closest rocky planet to the sun, but it never touches it. It has no moons. No nearby planetary companion. It moves alone, bathed in blinding light that offers no warmth. This becomes a metaphor for a deeply human experience, the feeling of loneliness in the midst of others. You can be close to people, even very close, and still feel isolated. Light can surround you, yet nothing truly reaches you. But Mercury also teaches us this: loneliness does not mean disconnection. Even though Mercury touches nothing, it is shaped by the gravity of the sun and of other planets. Its orbit, the way it moves, is the result of countless invisible forces pulling and pushing it. So are we. Even when we feel alone, we are still being shaped by invisible forces, memories, relationships, culture, history. We are never truly isolated. We just do not always see the threads that connect us. Remember that a single day on Mercury lasts longer than 2 of its years. This is not just a strange physical fact. It is a reminder that time is relative, not only in Einstein's sense, but in how it is experienced. An hour of suffering can feel like a day. A day of happiness can vanish in a heartbeat. The time we measure with clocks is not the same as the time we live through with consciousness. Mercury teaches us that there is no single way to experience time. An event can be fast from one perspective and slow from another. A life can be short in years and long in experience. What matters is not how much time you have, but how you exist within it. The surface of Mercury is a map of history. Every crater tells a story of impact. Every cliff is evidence of slow contraction. Every scar is a memory carved into stone. Mercury does not forget. It cannot forget. There is no wind to erase the marks. No rain to wash them away. No life to cover old wounds with new layers. Everything that has ever happened to it is still there, visible, measurable. This raises a philosophical question: is carrying every wound, every memory, a burden, or a form of honesty. On Earth, we can erase traces. We can rebuild. We can forget, or at least pretend to. But there is a cost to that. When we erase history, we lose its lessons. Mercury keeps everything. And in that brutal honesty, there is a kind of wisdom. Knowing where you have been, knowing what you have endured, is an essential part of knowing who you are. Mercury is a world of extremes. 430 degrees Celsius on one side, minus 180 on the other. No middle ground. No reconciliation. Just a sharp boundary between light and darkness. This is the opposite of Earth, where the atmosphere spreads heat, where there are sunsets and sunrises, gentle transitions between day and night. But perhaps Mercury teaches us that reconciliation is not always possible. There is not always a middle. Sometimes reality is made of opposing extremes, and you must learn to live with that opposition instead of trying to smooth it away. In life, we often search for balance. But sometimes balance cannot exist. Sometimes you must accept that certain things will remain opposites, suffering and joy, hope and despair, meaning and meaninglessness, and that both can be true at the same time. Mercury is the smallest planet in the solar system. Its mass is only 5.5% of Earth's. It is easy to overlook. And yet it changed the history of science. It helped confirm general relativity. It taught us about magnetic fields, about time, about the boundaries of habitability. Small does not mean insignificant. This is a lesson we need to remind ourselves of every day. A small action can change a life. A kind word can save someone. A minor decision can shape the future in ways we never see. Mercury reminds us not to underestimate the power of small things. Mercury orbited the Sun for 4.5 billion years before any intelligent being ever looked at it and thought about it. It does not need us to exist. It does not need to be seen, understood, or appreciated. It simply exists. In our age, where everything must be recorded, shared, and validated, Mercury teaches us the value of existing without an audience. That some things matter not because they are seen, but simply because they are. A tree falling in a forest still makes a sound even if no one hears it. Mercury still turns when no one is watching. And you, whether anyone recognizes it or not, still have value. Take a deep breath. Let all of these lessons settle. Mercury is not a teacher by intention. It is not trying to teach us anything. But in its silent, resilient, wordless existence, we can find reflections of ourselves, of what we endure, of how we persist, and of the strange beauty in simply continuing, day after day, in a universe that promises nothing except change. So if Mercury can teach us all of this, about persistence, about time, about meaning, then when we look up at the night sky and know it is out there somewhere, even if we cannot see it, how does that change the way we look at our own lives? Let's return to where we began. You are here, right now, listening to a story about a rock millions of kilometers away. A rock most people will never see with the naked eye. A rock with no life, no atmosphere, nothing but stone, metal, and searing light. But after this journey, Mercury isn't just a rock anymore, is it? We traveled through space, from a distance of 57.9 million kilometers, where Mercury orbits inside the Sun's glare, always close, yet never easy to see. We learned that sometimes, the things closest to us are the hardest to notice. We traveled through time, back 4.5 billion years, to when Mercury was born from fire and violence, forged in extreme heat, stripped of everything except its core essence. We learned that sometimes, loss leads to strength. We walked across its surface, among craters that tell a 4-billion-year-old story, among towering cliffs that reveal a metallic heart slowly shrinking, among regions of eternal shadow where ice preserves secrets from a colder past. We learned that scars are a kind of memory, and memory is a form of truth. We experience time in ways the human brain struggles to imagine, where 2 days last longer than a year, where the sun can rise twice in a single morning, where time itself runs just a little slower than on Earth as the sun's gravity bends space and time. We learned that time is not what we think it is. We felt invisible forces, a weak but stubborn magnetic field shielding the surface, solar wind hammering away and stripping atoms one by one, deep convection currents still moving inside a molten iron core that hasn't fully cooled. We learned that protection doesn't have to be perfect to matter. We asked questions about life, and learned that sometimes the value of a place isn't found in what it has, but in what it teaches us about what we have. We looked into the future and saw that Mercury will exist long after we're gone, perhaps surviving the sun's transformation into a red giant, perhaps orbiting a white dwarf for billions of years more. We learned that persistence doesn't need a purpose to be meaningful. And finally, we reflected on meaning itself, on what a rock can teach us about how to live, how to endure, how to exist in a universe that promises nothing but change. But now, let's ask the question that really matters. How does any of this change you? When you turn off this video and return to daily life, with its small worries, work pressures, complicated relationships, questions about meaning and purpose, does knowing about Mercury actually make a difference? I think it does. Let me tell you why. When you feel overwhelmed, when the temperature of life becomes unbearable, remember that Mercury endures 430 degrees Celsius every day for 4.5 billion years. No complaints. No quitting. Just continuing. When you feel alone, when you think no one sees you, remember that Mercury orbits in the sun's glare, nearly invisible, yet still an essential part of the solar system. You don't have to be seen to matter. When time stretches out, when a day feels like a year, remember that on Mercury, that's literally true. Time is relative. How you experience it is the only reality you have. When you carry wounds and painful memories, remember that Mercury's surface is a map of every impact it has ever endured. Nothing is erased. Yet it is still beautiful in its own way. And so are you. When you feel small and insignificant, remember that Mercury is the smallest planet, yet it has reshaped our understanding of science. Size is not a measure of importance. There's a quote by Carl Sagan I love, "The universe is within us. We are made of star stuff. We are a way for the cosmos to know itself." When you look at Mercury, or even just think about it, you are part of the universe observing itself. The atoms in your body were forged inside stars that died billions of years ago. The iron in your blood, the calcium in your bones, the carbon in your DNA, all of it once belonged to stars, just like the iron in Mercury's core. We are not separate from the universe. We are the universe, small pieces of it that organize themselves into something capable of reflection, feeling, and wonder. And when we wonder about Mercury, we're doing something profound. We're connecting with a part of reality that has no voice. Through our curiosity, we're saying, "You matter. Your story is worth telling. Your existence has meaning, at least to me, at least right now." And maybe that's the final lesson Mercury teaches us, that meaning isn't something we find. It's something we create, through attention, through curiosity, through caring enough to listen to the story of a rock 57.9 million kilometers away. Take one last deep breath. Feel your body. You're sitting or lying somewhere on Earth. Earth is spinning. You're moving through space at 30 kilometers per second as Earth orbits the Sun. And somewhere out there, unseen but always present, Mercury is spinning too, faster, closer, enduring more, yet part of the same universe as you. We're all dancing together through space, you, me, Earth, Mercury, the Sun, and countless billions of other worlds. All connected by gravity, by time, by the fact that we were born from the same cloud of gas and dust 4.6 billion years ago. And in this vast, incomprehensible universe, you, with all your thoughts, feelings, hopes, and fears, matter just as much as any planet. Because you have something Mercury does not, the ability to reflect, the ability to create meaning, the ability to love and be loved. Use that ability wisely. Live in a way that leaves you without regret when you look back. Persist like Mercury persists, not because you have to, but because you choose to. Exist fully, whether anyone is watching or not. Carry your scars as proof of a life lived, not a life avoided. And sometimes, when everything feels too heavy, look up at the sky at dawn or dusk and search for that faint light near the sun. You may not see it, but you'll know it's there. Still orbiting. Still enduring. Still existing. And if Mercury can survive 4.5 billion years of fire, violence, and isolation, then maybe, just maybe, you can make it through today. That is the truth and the mystery of Mercury. Not all the truth, because there is still so much we don't know. And not all the mystery, because some mysteries are meant to remain unsolved. But perhaps that's another lesson, that we don't need to know everything to appreciate something, that mystery isn't the enemy of understanding, but an invitation to keep wondering. Breathe. Open your eyes. Return to your life, but with something extra. A little awareness of your place in the universe. A little humility before the scale of time. A little courage from knowing that existence itself, simple, imperfect, persistent, is enough. Thank you for taking this journey with me. Thank you for giving your time to listen to the story of a small rock. In a universe where most things are never noticed, your attention is a gift. Go on and keep orbiting, like Mercury, like Earth, like all of us. And remember this. You are part of something far greater than yourself, and you are also completely enough, exactly as you are. Thank you for staying with me all the way to this moment. If this story touched you in any way, please consider liking the video and subscribing to the channel. Not for the algorithm, but because it lets me know that stories like this, stories that blend science with poetry, facts with quiet reflection, matter to someone out there. I'm genuinely curious, where are you listening from right now? Somewhere on this earth, in which country, at what time of day? Leave a comment. I love knowing who these words are reaching, where they land, and when. And wherever you are, whether it's the middle of the day or the heart of the night, under sunshine or rain, in joy or in sorrow, I wish you this. May you have enough light to see the road ahead, and enough darkness to rest when you need to. May you have enough warmth to keep your heart alive, and enough cold to calm the storms in your mind. May you have enough time to finish what truly matters, and enough wisdom to know that some things will always remain unfinished, and that's okay. May you move as Mercury moves, unhurried, uncomplaining, simply existing, day after day, within this strange and beautiful universe. Rest well. Live well. And remember, you are made of stars. I'll see you in the next story.